Hello, this video is to demonstrate a prototype multiplier circuit. It's not completely automated. I use this sort of control board that I will manually operate for the moment. It is a prototype, so keep that in mind. I'm going to multiply whatever's in this A register by whatever's in this B register. This is currently 5 times 2, and the result will be 10. And I will use the simple process of repeatedly adding and shifting A. And the control of the adding and shifting is being done here by the shift register. I'll start out, what I'll do is I'll copy B to the shift register. When the low bit of B is 0, I won't add anything. When it's 1, I will add A to my running total. And then I will shift A and repeat those steps. You can work this out on a piece of paper. It's fairly straightforward, the binary multiplier using this method. I will issue a series of steps. The first 2 steps are setup. The first step is I will just copy B to the shift register. So this shift register can shift to the right, A can shift to the left. Just making note of that via control lines. I already did a video on how to build a shift register. So currently stored here is 2 in the shift register, like I want. My next step is to actually clear what's in the B register. So that's now 0, and the reason that's 0 is because I'm going to add A to it. I need to start out with 0. That's my running total, which is currently 0. Okay, hopefully that is clear. So the first step, I'm going to issue 3 steps and repeat as necessary. I only need to repeat a couple times here because it's fairly small numbers. I will activate the right ALU circuit. Now, that would write to the ALU, where the ALU is constantly adding the A and the B register. If I do the right, it will fix that value over here in these D latches. I can't remember if I did a video of my ALU or not, but that's how that works. Okay, so, but it's not adding it because I have an AND gate here, and that AND gate says it will only write to the ALU if the switch is on and the low bit in the shift register is not 0. It's 0, so there's nothing to add. That's exactly what we would expect, because that low bit controls whether or not we add. Okay, so then I will do the shift and copy step. So what that's going to do is it's going to copy whatever is in the ALU working memory into the B register, which is 0, because I basically didn't add anything. And it will shift A, so what was now 5 is 10. Every time you shift to the left, it multiplies by 2. That's how binary shifting works. All right, so the final step is to shift the shift register value to the right. And what is now in that is 1. So now we will repeat our steps, starting with the right ALU. So that should basically add whatever's in B to A, which is 10 plus 0. So I'll flip this right ALU switch. I'll go back to the ALU and I'll show that that is 10. All right. Okay, and then finally we will do our shift register shift again. And that is now 0, so we are done. I guess if we make this fancy, we could just build an automated control logic that would loop through until that shift register low bit is 0. Hopefully that gives some idea of how you could do a multiply circuit. This is obviously a monstrosity in a prototype, but I wanted to get the video out to give people some ideas if they had not seen this type of logic before. Thank you for watching.